Hello everyone, welcome to AWS and Linux Foundation course. And the today agenda is to talk about the process management. Okay, so as part of the today delivery, we are going to understand the Linux process management, the different process states, and how do we manage the services in the Linux, which is a important session that is. The prerequisites for us to go to the next level of discussions to configure our web applications, right? Well, let's see a few details about the process management. So I have this slide for you guys to present. Okay, so as of today we have understood that the Linux is the complete command line operating system where you can logging into the Linux and will get a bash prompt symbol. You execute a command and the command will be get executed. You get a fruitful output based on the command and the flags that we are using, right? Good. So let's see what is it mean by the process terminology from the Linux perspective, right? So ideally, you are actually executing a command, right? The command could be anything. It could be a ls command, mkdir, or a touch command, or maybe a log rotate command that we have discussed in the last lecture to manage the log rotation policies of your log files, or it could be any script, right? Any command that you are executing definitely is having a absolute path, which is the complete path where the binary file is stored corresponding to your command or a script, correct? If I take ls command as an example, the ls command, the absolute binary path is in the slash usr slash bin location. So when you run the ls command, ideally what will happen, that usr bin ls, that binary file will be get executed and you get a output. Ideally, for ls command, the expected output will be the list of files and the directories on the directory that you have been specified to your ls command, correct? So when you run this command, what will happen exactly? That is what we are trying to understand now with this process management. Ideally, when you run a command, the command binary file will be get loaded it into a real memory. So any system will have a memory, right? The RAM that we call it as, right? So the real memory is the space where the commands will be get loaded whenever you execute a command. The moment when you execute a command, the command instance will be get loaded it into the real memory. Once the command instances are created in the real memory, that is now called as a process, and every process that is created in the real memory will be assigned with one unique identification number that is called as a process ID. Well, so that means when the command is loaded it into the real memory, the process is created, the process name will be the same as your command name, correct? This is just a terminology changes. When I say command, that is available at your uh, absolute path, which is your binary file, right, where the script is located. And when that command is loaded it into the real memory, then the terminology called process. The process is created. I would say when the ls command is executed, then the ls process is created. Let's say if you have executed a mkdir command, then the terminology will be mkdir process is created, right? Every process that is created in the real memory will be having a ID that is called as a process ID, right? So once the process is created, then that process has to be get executed by your processor. Ideally, the way how the system works, a computer works, right? All the tasks or the commands or the instructions that you are executing will be loaded it into the real memory. Then those processes will be get scheduled for the CPU turn, right? The processor is the one which is actually executing that instructions and giving you the right output. So the process has to be get scheduled for the CPU turn. When the process is actually getting scheduled for the CPU turn, the process is going through different states. Once the process is created and it is admitted, in the sense once it is accepted it to run as a process, the process state will be in the ready. When the process is in the ready state, in the sense the process is now ready to hand over to the processor for the execution. The processes that are in the ready state, those processes will be now get scheduled for the CPU for it to run. So once the processes are submitted to the processor, the moment when it start executing them, then that process state is called as a running state, right? Well, so sometimes, when the process is created and the process is currently running by the processor, your process may take a shorter time to complete. Your process may take very longer time as well sometimes, right? Based on what kind of the command that you executed, how much time the command takes, right? It all depends how much time that the processor has to spend on this command in order to complete the command and give you the output, correct? Well, so when the process is actually running by the processor, sometimes it may be executed immediately, sometimes it may even take a time. Sometimes your process may be waiting for input as well, right? Let's say you execute one command, it is expecting some other information as a input, and that time the process cannot be completed until unless you provide the required input, right? So if the process is waiting for something, then that process will be putting it into the waiting state. The waiting state process is again putting it into the ready state after some time, and again those will be get scheduled for the CPU turn. That is how the cycle will happen in at the time of the processor is actually executing the processes. Good, right? And why all these things? A processor by default can execute only one process thread. I mean to say, let's say the multiple users are logging into the Linux system, as the Linux is the multi-user operating system. If all the users are executing a command at the same time, right? And let's say your system is having only one processor in it. So do you think that the processor will be executing all the user commands at the same time? No. Ideally, the processor can execute only one process thread at a time. So if there are 10 processes are created, right, at the same time running by the 10 different users, the processor will be executing only one process thread at a time. The rest, the 9 process threads will be either in the wait or in the ready queue, right? Once one process is completed, then it will take on the other process. That is how the processes are actually executed in a sequential fashion. Because the processor is actually spending very milliseconds of time for each process, ideally you will not recognize that delay, though it is actually executing the processes in a sequential fashion, right? Because it has to give that kind of a view to the users that all the commands are actually running at the same time. The processor is actually spending only less process time on each process. Let's say if there are 10 processes that are created at the same time, the processor will spend some, let's say, 10 milliseconds in one process. If that is completed within 10 milliseconds, good. If not, let me put that process back into the waiting queue or going back into the RAM queue again, so that it will take on the another process. It will execute the another second process for 10 milliseconds. Again, that process will be either exited if it is completed, or else the process is going back into the queue again. That is how it is having the fixed cycle, how much time that it has to spend on each process thread, and it is keep on rotating the process threads in the queue. That is how it is giving a intensive to the people that all the commands are actually executing at a same time, but that is not a real. Correct? We cannot recognize that delay because the process is spending only some milliseconds of time, and we do not see that difference when it is actually executing the sequential processes and your process is in the waiting state. Good. Let's say the process is scheduled for the processor turn and it is in a running state, right? And as usual, right, if the process is completed it will be done, or else it is going to the wait state. Sometimes your process may be interrupted, in the sense what, the process is currently executing one process, and during the time of the execution if any other process come as an a priority, then that process will take a precedence, right? So the current executed process will be interrupted by the emergency process, and this process will be putting it into the queue again. That is what does it mean by the interrupt. Now when the process is completed, in a sense, for what purpose you have executed a command, if you are able to get that output, then that means the process is completed, right? So once the process is completed, then that process will be exited. So that is called as a process termination process. Good. That means if you have executed a ls command, if you get an output of the list of files and directories, that means you got the required output. The ls process is terminated. If your command is mkdir as an example, if the directory is created, then your process will be terminated. That is how once the output is generated, then the process will be terminated. Once the process is created, is mean that what? Your command instance is actually loaded it into the real memory. Ideally, what will be the size of the real memory in a typical system, guys? It's all depends on the size of the instance or a server that you choose, right? If it comes to the AWS world, the instance type that you take on, that will decide what is the amount of real memory that will be allotted for your EC2 instances, correct? Ideally, it could be 1 GB memory or 2 GB, 4 GB, that is maybe a 8 GB. That is the typical mid-range of the servers will be having, correct? So when the process is loaded it into the real memory, the process will be consuming some space from the real memory, guys, correct? Let's say your real memory size is 1 GB, and let's say there are hundreds of commands are getting executed. Hundreds of command instances will be get loaded it into the real memory, and each command is taking some space from the real memory, and your real memory 1 GB space may be fill up with all the processes. Let's say your real memory is completely filled in. 100% real memory is filled with all the processes that are actually created. If the real memory usage is 100%, during that time, if any other user is executing a command, do you think that that command will be get loaded it into the real memory to create a process? No. Why? There is no space left in the real memory to create a new process, because each time when it is creating a process, some space will be consumed in the real memory to load it. And there were a lot of processes that are already created. Those commands are already loaded it into the real memory. Let's say the real memory space is all over, right? So if you get into that situation, then when you execute a ls command, you get a error saying that out of memory, right? So when you get a error out of memory when you are running a command, is mean that the real memory is 100% full and there is no space left in loading your command as a instance it into the memory to create a process. Good. Hence the reason, ideally, once the processes are created and consuming the space from the real memory, once the process is admitted, ready state, running state, once the process is completed, once it is terminated, the system will ensure that the terminated processes will be get deleted from your real memory. That's a good practice, right? So that I really do not require to keep the processes in the real memory, though those are terminated, correct? Because the you got output and I don't need it to be keeping in the real memory. Like that, as much as possible, it will try to remove the process information from the real memory once a process is terminated. That way, the space will be left over in the real memory. That space can be used to load any new processes or new commands or script that you are going to execute. Good. So sometimes what will happen, right? Though the process is terminated, you got a output, but for some technical reason or for some reason, your process cannot be removed from the real memory. It will try to remove the process information, but it cannot remove the process information from the real memory. That kind of a situation is called as a zombie process. So there is a terminology called zombie process. Zombie process is mean that the process that is still there in the real memory, though it is terminated. Ideally, the zombie processes I don't need to keep in the real memory, which is consuming some space, which is eating some space, and I don't need that kind of a processes because it is already terminated technically and I got a output as well. Correct. If the more number of zombie processors are increasing in your system, as these zombie processes are lying in the real memory, eating some memory space, there is a high likely chances that all of your real memory will be filled with the zombie processes, which will not be get deleted, and your real memory space will be consumed. It will go to 100% usage, and there is no space left over in a real memory to load any new processes. That kind of the bad situation will arise if the more number of zombie processes are increasing in your system. Good. Ideally, the real memory, which is storing the details about the processes, is the volatile memory. In the sense, if you shut down the server, all the data that is in the real memory will be completely erased. When you start the system again, the moment when the scripts or the commands are getting executed, again it start loading those it into the process in a real memory. But when you shut down the system, all the data will be get erased from the real memory and the real memory will be get loaded again when you start the system. This means that if if there are more number of zombie processes in the real memory that is eating up the space which are not getting deleted, and some of the space is wasted there because of the zombie processes. If that is the situation, the only solution to fix this issue is to restart your system. Agree with me? Because if you restart the system, as you know that the real memory will be get cleaned up completely, the system will start up with a fresh, right? So only the new processes will be get loaded it into the real memory. That is how we need to take care of these things. Well, so this is the background what will happen when you run a specific command or a script and how these processes are maintaining. And as I said, this is how the zombie processes will be get created, which we don't need it in the system technically, right? As the zombie processes are a stale processes. Good. Now, how do we see this information in the system? As usual, I have created a EC2 instance from my AWS console and I'm logging into my EC2 server using my putty, right? Now, whenever you run any command, same process is happening. Let's say ls command, the ls process is created in the real memory. Process will be submitting to the processor for a execution. The command will be executed, you get an output, then the process will be terminated. All those things are happening behind the screens for you. Here the ls command is very quick. Within a milliseconds or microseconds of time, you are able to get a output, right? In this case, the output is empty, not a problem. If there is a list, it will show you or else no, correct? Well, so how do I see the processes that are in the running state, right? So ps-ef is the command to see the processes that are currently consuming the space from the real memory and that are in the active state. Active state in the sense the processes that are currently in the running state, right? If you see this command, the ps-ef is giving you a nice output, right? How should I be understanding this output? The first column is talking about the username who is actually executed a command or a process, correct? The command, script, process all are same, guys. The command or a script is the generic terminology when it comes to the hard drive level or a binary file level, right? Process is the terminology when it is loaded it into the real memory. That's only the terminology changes. So when it comes to the ps command, as we are actually looking into the processes information that is currently running in my real memory, so my terminology is the first column is talking about the OS level username who is currently executed a process. The last command or last column is talking about the process name which is currently executed by that particular user. Good. Here you can see a lot of processes. Whatever the name that you see in the last column, all these are the processes, guys. You cannot understand these processes technically because all these are the processes that are currently running in order to ensure that your operating system is up and running. Possible, right? The way how the ls process is created and giving you the output, even if your operating system has to be up and running healthy, there should be some processes running on the system continuously to ensure the uptime of your EC2 instances or servers. So all these are the internal processes that are executed by the system automatically for you using the root permissions to ensure that your system is up and running safely and securely. Correct? But there will be some processes that you will be executing as per your custom requirement. Those are called as a user processes, right? So just to repeat, these are the system processes that are running just to ensure your system is up and running. Whatever the process that you are creating, those are called as a user processes. Here you can see that the EC2 hyphen user is actually right executed a I think let me go here, right? EC2 hyphen user is a user who is actually logged into the server. He is currently active. Even logging into the server is also treated as one kind of a process, and that process is still active. Why? The EC2 hyphen user is still logged into the server. And you see the su hyphen command is executed, sudo su hyphen command is executed. The bash shell is currently active, which is giving me a prompt symbol for me to execute a commands. Anything that happened in a Linux system is actually a process. It is not only just a command that you are running, right? Even behind the screen, right? Everything will be a process. The process must be loaded it into the real memory, and that has to be processed and that has to be executed, guys. That's what I'm trying to explain from this table. The ps command, whatever I'm running here, is called as a process table. So whatever the output that you see, this is called as a process table. Every process that is getting created will have a process ID. So if I go a little up, The second column is talking about the process ID. You can see the process ID, which is the unique number that is assigned for the each process. Ideally, the very first process that is created by the system is called as a process ID 1. You can see PID 1. This process will be created the time when you switch on the machine and when it is actually initiating your booting process to make your system up and running. Then onwards, whatever the sub processes that are creating, all those will be assigned with its own unique number called as a process ID, right? And even if you go little down, you can see that even sudo hyphen command is also initiated with a process ID, assigned with a process ID, correct? Now, each command will have a parent process ID, guys. Sometimes, one process may lead in creating another process, correct? You see here, the process number 2 is actually a parent of the process ID 3. So that means the process that is having the process ID 2 is actually causing as a cause to create another process. That's how every process will have a process ID and the parent process ID as well. Even here, if you see, the sudo su hyphen command is executed. This command process ID is 3292, and you can see the parent process ID. Who is the parent? The parent is 3269. 3269 is actually the process ID of the other command. That means technically the EC2 hyphen user is running the sudo su hyphen command, but in the backend it actually, right, it is treated who is the parent process. Bash shell is the parent process. That bash shell is actually running the sudo su hyphen command. That's how you can see here the relationship between the parent process and the child process. It's all automated in generating the process ID, parent process IDs, but we should understand how the processes are getting created in the Linux system, and we are going through that process table to understand all these details. Good. Any user who is logging into the Linux system will have a terminal, right? Let's say here I logged into this Linux system using my putty. The putty screen, whatever you see, is called as a terminal. Even this putty terminal where I currently logged in will have a name, the terminal name. The terminal name can be seen by running the command called tty. TTY is the command to see what is the name of your currently logged in terminal. You see, the currently logged in terminal name is /dev/pts/0. Even if you see the ps-cf process table, you can see here that these processes are created by the specific user, the process ID, parent process ID. You can see that this process is actually created from which terminal. My currently logged in terminal is pts/0, and you can see the terminal here. If any other user logged into this server, even that terminal also will have their own name, and the terminal name also will be displayed here from which terminal these guys are running these commands. That kind of a complete view will be seen in the process table here. Let's say I'm running a ls command and hit enter. Now the question for you, can I see this ls process in my process table? You don't. Why? The process table will give you the processes which are currently active running. But the ls command, is it active? No. Within a milliseconds of time, the process is completed. You got a output. Once you got output, the process will be terminated. In a sense, it will be removing it from the process table. You can't see that processes in the process table. Correct. So if you need to see the active processes in the process table, make sure that your process is not terminated, correct? I will give you one concrete example here. Let's say I'm using the vi command here to open a file and modify some content, and let me hit enter. Currently, I'm inside a vi editor to do some changes to my file. So, do you think the vi command also will be a process, right? At the end of the day, do you think the vi process is terminated here? No. As long as you are in the file in the editor to do some changes to your file, your vi process will be in a active state, correct? Can I see this vi process in your process table? Technically, yes. But in the current terminal, because I'm already inside a vi editor, I don't want to come out from the editor. So in order to see the vi process in the process table, let me take a one more session. Let me logging into the other session. Let me go to root and let me run ps-cf. Now you should be able to see the vi command here. You see here, guys, vi, vim both are same, guys. Okay, and the vi command absolute path. Let's say, where is vi command? You see, usr bin vi is the absolute path of the vi command, and I can see here that usr bin vim is the command that is currently executed by a root user using this process id. It has a parent process. This is executed on so and so terminal, and this particular vi process is currently a active process, and I can see that in the process table, and this vi process is consuming some space in the real memory as it is a running active process at this time. Good. In the other terminal, right, let me come out from this vi editor, guys. Can I say this process is terminated because you are done with your command? The command is completed, the process is completed, it's terminated. Definitely the process information, right, should be get deleted from the process table. Now if you run the ps-ef, you will not be seeing that vi command anymore because the process is completed. Is it good? The VA I'm taking one as an example just to show you that as long as the process is in the running state, I can see that process is in the process table. Let's say I'm in the VA editor again. Let me come back to other terminal and run ps-cf. Now you can see that the VA process is created, the process ID is generated. Now, when this process will be deleted from the process table, only when the process is terminated. The process can be terminated in two ways. A graceful force. Graceful in the sense whoever is executed a process, right, that user has to come out from that process or let the process is completed, right? Whatever the output that you are looking for, the output will be generated and the process is completed gracefully. The second method, right? The process is created by one user in the other terminal and you are able to see that process in the process table. Let's say you don't want this process to be running. Then you take the process ID, then you use the command called kill. Kill space process ID. Kill command is used to kill the process and you hit enter. Now you verify the process table one more time, right? Now you see that the VA process is not available. So I have killed the process by taking the kill command help and specifying the process ID. You may be wondering now what will happen to the VA editor that is actually opened in the other terminal, right? If you go back to the other terminal where VA command was opened and you see that caught deadly signal term and you can see terminated. So wherever that process was actively running, that process is actually terminated because the corresponding process ID is killed. Let me open the VA editor again just to show you a few more commands. You see, again the VA process is created. Sometimes when you are using the kill command to kill the process, whenever you feel that that process is not required anymore, you can use the kill, or you can use the kill hyphen 9. Basically hyphen 9 means force. Sometimes no, even the kill command cannot kill the process because of various reasons. When the process is really busy and doing a lot of work and it cannot kill, you can use the force flag to kill a process, and definitely the process will be get killed. But from the best practice perspective, we should not use the kill command to kill a process without taking the confirmation from the user who actually executed a process, called as a process owner. Let's say any process, you can definitely see a process owner, right, who executed that process. You inform to that process owner that, hey, this is a process currently running, I wanted to kill the process. You take the approval from the user, then only you have to kill the process, because we don't know exactly what process that is and why that user is executed that process, right? That's the reason. But if with all the due diligence and the process and still you wanted to delete, sorry, terminate, you can use the kill command to kill a process, guys. Good. Let me clear the screen. Definitely now in the other terminal, you see the process is actually killed, right? And it is actually came out from the VI editor. Well, now the story is there are some processes that can be executed immediately within milliseconds of time and can be completed. But there are some processes which will be taking a longer time, right? Let's say a command that may take 10 minutes to complete. I cannot demonstrate such command as of now, which commands will be taking longer time to complete, right? But let's say there are some commands which will be taking longer time to complete. Okay, then how do we manage such processes, right? Maybe I'll take some example here. You see, guys, sleep is the command that I'm executing, and the number that I pass here is in terms of a seconds. This command purpose is, right, hey, wait for 100 seconds of time, then the command will be completed. Ideally your processor is not doing anything when it is executing this command. The processor is just waiting for this much number of seconds without doing any task. That is the purpose of the sleep command itself. Got me? I am just using this command just to show you some example, the commands that will take a longer time, right? So ideally the ls command is terminated immediately, right? Because it is taking just less number of milliseconds to complete a output. But usually if the commands are taking longer time, until the command gets completed, you see the behavior, guys, you are not getting a bash prompt symbol, correct? When you are running a command, okay, when you are running the command and the command is not giving you a bash prompt symbol to run any more few more commands, then this kind of a behavior is called as a foreground process. Now I can say, I can use the terminology called the sleep command is actually running in the foreground. That's the reason I'm not getting a bash prompt symbol to run any more commands. I need to wait until this command is completed. Then only I will be getting a bash prompt symbol to run any more commands. You see, it waited for 100 seconds. Once this command is completed, then only I am getting any more commands. That is called as a foreground process. Ideally, if the commands are very quick and giving you the output immediately, you are getting a bash prompt symbol, no issue, right? But what is the case if there are some commands that are taking a longer time? Should I be waiting until the command gets completed to run any more commands? No. Such situations, you need to run a commands in the background. Any command that you are expecting to be run in the background, the command should be end with a ampersand symbol. If you give the ampersand symbol and at end of the command, then the command will be in the background. In a sense, you will be getting the prompt symbol. You see, I got a prompt symbol to run any more few commands, but this command is not yet completed. This is still running, but it is running in the background, right? Any command that is running in the background because you have added a ampersand symbol there, right? That type of commands will be giving you a process ID in the prompt. You see, it's telling that, hey, this command is not completed yet. It is still running in the background, and this is a process ID that it is assigned with to run this process and to track this. Let's say now I wanted to know whether this command is completed or not. When it is completed, always you go to the process table and look for this process ID. Let's say I'll go to ps-ef now. 3784 is the process ID of this process, right? The sleep process. You see, 3784 is a process ID, and you see that the sleep command is still running state. That's how we need to track the processes that are currently running in the background. Now let's say you don't want this background process to be running. Obviously, because you know the process ID, you can use the kill command and kill a process ID, then that particular process will be get terminated. Or else it will wait until the time when the command is successfully completed, then you get a output whatever you are expecting, then the command will be terminated, then the information will be get deleted from the process table. That is how it works. You see, when I'm killing that process ID, and you see I'm getting this kind of a output saying that this particular background process is now completed. This is completed just because I have actually killed it. Let me clear the screen. Let me run the command one more time. That means whenever you are running any command or a script, it can be run in the foreground or a background. Ideally, if your command is taking less time, run it in the foreground. If it is taking a longer time, better to run it in the background. Let's say your command is in the foreground, but still you don't want to continue with this process. Obviously, you can use Control C to kill this foreground process. That's it. If you can't wait for that longer time, you just use Control C so that the foreground process will be get killed and you get a bash prompt symbol and you continue running any more few commands, guys. Now, let's say I'm running a foreground command, a foreground process. Of course, you know that if you wanted to kill, you can just use a Control C. The question that I have here is, for some reason, let's say my session is disconnected, my party is closed, my internet is disconnected, network is problem. So do you think this command will continue to be running on the system? No. Any foreground process that is currently scheduled will not be continue running on the system if the current active terminal closes. That is the biggest problem if you are running a foreground process that is taking a longer time. Let's say if my command takes 30 minutes of time, for that 30 minutes your network connectivity should be fine, your party window should be fine, then only the command will continue. In between, the network is disconnected, your command will be get terminated automatically. That is the foreground behavior. But when I'm running the commands in the background in the sense the command is scheduled to run background in the system. If you don't want the command to be get stopped, though my network is disconnected or my session is closed, then you need to use a command called no hub. No hub in the sense no hang up. If you give the no hub as a prefix to the command, then the meaning is, right, this command should continuously be running on the system, right, though the partition closes, though the network is disconnected, but still this command should be in a continue. That is what does it mean by the no hub, and you hit enter. As this is the background process, you are getting a process ID, and as this is the no hub, this command continue to be running in the background. And by default, as this is continuously running in the background and though your partition closes, if this command is producing any output, let's say this command is giving you some output, if your party closes, where that output will be get displayed, correct? That's the reason by default it creates a file called nohub.out in the present working location. If any output that this command is producing, that output will be get displayed in the nohub.output file. That is how the behavior of the nohub, how it will be. So that later once you reconnect back, if you wanted to know the output of this command, you just go to the nohub.out and see the content of the or output of the command, guys. That is how the foreground and background processes will be running and can manage all of them using the process ID. Can I use this statement at this time? If anything has to be working in a system, the process must be in a running state. Without a process, nothing will happen in a system, correct? Could be a LS or could be any other. If something has to be running state, the something has to be working state, the process must be in a running, correct? Now, I'll take one concrete example here. Okay. Let's say I'm taking the help of the cron tab to schedule a job, right? As you know, the cron tab is the job scheduler, right? Let's say I'm using cron tab -e command and I'm scheduling a job here. Let's say at 0th minute, let's say at 4th hour, every day, every month, any day, I wanted to run a command called touch to create a file. As an example, I'm using touch command. It could be any command that you would like to schedule, correct? Let me save the file. You see now cron tab -l. You know that if you schedule a job in the cron tab, then when the time match this schedule, your command will be get executed automatically. Now my question is, now you close the terminal, you log in back after some time, still your job is scheduled and the job will be get executed. The question is, who is responsible here to keep track of these jobs? Correct? Think of like a human. If I give you the schedule that hey, at 4 o'clock please do this activity, someone has to remember that time, someone has to look after the current time. Yes, the time matches, this activity has to be done, go and execute the command, correct? Who is doing all these activities, guys? Got me? Process, correct? There should be one process that is running in the system. That process is responsible in watching out for your cron tab entries, watching out for your, the schedules, looking at the current time and executing the commands. All these things are actually done by a process. Like how the ls process is responsible to give you the list of files and directories, there is a process called cron d process. This process is responsible in looking after all of your cron schedules and making them executed. Then the question for you. First of all, let me see this cron D process is currently running on my system or not. Let me run ps minus ef command and let me looking into this output. Somewhere you can see this cron D, right? Cron D is the process. The absolute binary path of the cron D process is user has been, and this process is currently running with a PID called 3149. Good. So can I use this statement? Because this cron D process is currently running, this process is responsible in watching out for the cron top schedules and making them executed when the time comes in, correct? Then the question for you. So do you think that this process should be get terminated at any time? No, right? That means there are some processes that can be executed immediately once the output is generated. But when I talk about this process cannot be get terminated. Why? There will be multiple job schedules scheduled by the cron tab, and the process should be continuously running on the system, right? And to keep watching out for those schedules. If this process gets terminated, then your jobs will not run because no one there to monitor, track to run them, right? So can I consider the difference between the ls process and the cron D process, guys, at least? That means ls process is the process that can be executed and terminated immediately within a milliseconds of time because the output is generated. But the cron D process is a special process which cannot be terminated in a system, because if it gets terminated, my job schedules will not run. So this is the process which is continuously running on my system from the time you start the system till the time you shut down the system. Agree with me? The processes that are continuously running on the system without a termination, that type of a processes are called as a services. The all the story here is just to give you the terminology introduction called what is a process. Sorry, what is a service? Now, if I ask you what is a service, guys, a Linux service is a process, but it is a special process which is continuously running on the system from the time when you start the machine till the system is going for a shutdown, and your service is continuously running. Why? That service purpose is like that. It's not like generating some output and going for a termination. No, it has to be running continuously because it has to keep on watching for something, and it has to do some activity as and when needed, right? So those are called as a services. The services that are continuously running in the system, right, without them to be terminated, because if those services are terminated, and there is an impact on certain other things, right? Like if the cron tab is if the cron service is terminated, your jobs will not run. That's the impact, right? The services that must be running continuously on the system, those services are listed in a location called slash usr slash lib slash systemd location, right? In the usr lib systemd, you can see a lot of files. All these are the files, right, which are responsible in managing your services. I'm sure there will be a cron D as well. Give me a second, guys. I'll take you guys to the right location. You see here slash usr slash lib slash systemd slash system. This is the default directory where all the services are listed. If you do a ls minus cell, you can see the files that are having dot service as the extension, guys. And I'm sure there will be a cron service definitions as well here, right? If you slowly look into the list of files that are available in this location, right, there will be a cron service as well. I mean to say, any service or any process that must be running as a service continuously on the system, those are actually configured in this particular location. Let me try to search for cron. Right, this is the name of the file, guys. Well, you see crond.service is the name which is available in the systemd path, and because the crond.service is configured here, this is treated as a service. I mean to say, when you switch on the machine, when you start a system, how it know that which processes should be get started automatically as a services? Correct. That is where it is configuring all of them in this location, and this crond.service file is having all the details how it has to start your crond service or a process. You see this slash usr slash sbin slash crond, that is the actually a binary path of your process, right? Like how a ls command is having absolute path. So this command will be get executed automatically when it is actually handling this particular crond service, because it has to run continuously on the system. That's how some default settings are already added in the system location, and all these services will be managing accordingly, guys. This is good that there are certain processes that are continuously running on the system to make some responsibilities. Can we control those processes? I mean to say, can I start, stop, terminate a service? Got me, guys? Sometime back I have shown you that the VI process, right? The VI process can be terminated by running the kill command, correct? You see here, the VI process is assigned with a process ID that I can kill it so that the process will be terminated. But here I can see a cron process. The cron process is also having a PID. Now the question is, should I be killing the process ID of a cron process to kill this process if I wanted to? No. Though this is a process, but this is a special process which is continuously running on the system as a service model. So to handle the services, right, to manage the services, right, there is a command called systemctl. Systemctl is the command that will be managing the services on a Linux system. This command will help you to verify the status of a service. You see, systemctl status crond. I wanted to know the crond service status, and it is telling that this service is successfully running. This service definition is successfully loaded from this location. That is where I have shown you some time back. usr lib systemd system, right? This file is loaded to run this particular service, and it is running state. This service is currently running with this particular PID. This is the service name. You got a lot of information about it, right? That's how it is. So do not use any process ID of a service, guys. Though this is a process, but still, as this is acting as like a service, use the systemctl command to control the status of a service. Systemctl stop is the command to stop a service, and see the status again. You see that the service is currently inactive in dead state. Is it a best practice to stop a service? No, right? Ideally, stopping a service in the sense that process is terminated and that process is not running and it cannot do. the corresponding activity. At least this time, cron D is the service which is responsible to watch for the cron schedules and making them executed right on the time. That will not happen now because the service is stopped. Systemctl start is a command to start a service and you verify it again. Like that? Yes. You can control these services using systemctl command, stop, start, status, and you can even go for restart. Restart in the sense the service will go down and it will be starting again, guys. That's what is mean by the systemctl. And systemd is the service manager who is controlling all of these services. That is the reason the service definitions are under the systemd path. So if you ask me the question, what is systemd? Systemd is the service manager which is managing the services in the Linux system. The systemd is providing you the systemctl command line utility to manage the services by yourself. If these services has to be running automatically after the system reboot time, then you need to run a command called systemctl enable cron D. What is this command? Let's say you reboot the server. After the reboot, you are expecting that this service should be started automatically. Then you need to run this command. If you say systemctl disable cron D as an example, so what could be the right command, guys? Right? If you say systemctl disable, is mean that hey, do not start this cron D service after the system restart automatically. So there will be different situations, right? Sometimes you may be expecting the service to be started automatically. Sometimes you don't want the service to be started automatically based on the different requirements. Here I'm calling about cron D as an example, how just to show you how the systemctl command works. But tomorrow, right, there will be different number of services that we will be working on. So whichever the service that you feel has to be started automatically, which you don't want it, all these things can be controlled using the systemctl enable disable command line. Let me clear the screen. Can I use this statement now? In the Linux system, the services must be in a running state in order to do any activity. Agree with me, guys? The services are the processes only which will be running continuously in a background for you, and those are actually doing a certain task based on what type of service that it is designed for. Cron D is one service example that I have shown you. The cron D is a service which is continuously running on the system, which is responsible in watching out for the cron schedules and making those cron commands executed when the time matches to that schedule. Like that, there are a number of services are there. We need to learn all those services, each service purpose, responsibility, how to control the service, what job that the service is doing, and we need to understand that, guys. That means we are leaning towards in installing, sorry, downloading, installing, configuring a service which is serving some services to the end users like a web services. In the next lectures, we will talk about the web service, how that is installed, configurable, and how to make a website live, which will be accessible to the end user. All those things will be discussed. So this is the introduction for you guys to understand what is a service and how a service will be manageable and how the service will be make available. Here, the Conda service is installed by default as part of your EC2 server. You don't need to install it separately. But sometimes, There will be some services that you need which will be required for your business purpose. Those services are not available. Yes, then you need to understand how to install a service, then configure the services that we will be seeing it in the upcoming lectures. With this, right? So we are done with understanding the process management, process ID, parent process ID, the services, the one more terminology called daemon. The services that are running continuously on the system are also called as a daemon. That is the reason any service that is actually running continuously on the system will be ending with a D. You see this? Cron D. D refers daemon, right? That is just a terminology, guys. Daemons is mean that a service that is running on the system which is controlled by the systemd service manager using systemctl command. One last command that I wanted to show here, psaux command. This command will tell you the process state. You see here, this column will give you the state, right? I means like informational, S means sleeping process, right? So you can see the different states. If you see anywhere Z, Z is mean that a zombie process. That's how we need to know at least if is there any zombie processes in the system, we should be able to look after this particular column. Is there any way showing it as a Z, right? Only the Z is concerned, that is a bad state, and any other state is not a problem. So the process, right? That's how we can see the process states by using psaux command to. Well, team, I think that's the story for today. So, if any questions, do let me know, or else we are good and will be, going to little advanced of these sessions in upcoming to meet our goal to build, sorry, to deploy a web server and make a website accessible from this EC2 server. Thank you.